Hi everyone, I just wanted to create a short video. This is on finding volume. It's for lesson 1.07 and this is going to go through how to find volume using unit cubes. So what does that look like? So just be sure you have your pencil and your notebook, and I would write these two examples in your notebook so that you can refer to them when you're taking your assignment. All right, let's just dive into a question together just to see what it looks like. So if I were you, just pause the screen and write this problem in your notes. And we're going to look at this problem going through how to find the volume using unit cubes. So just be sure to pause the screen and write this down. And let's fill in what we know. So it says a rectangular prism has edges that are 6.5, 2, and 2.5 inches long. So when I look at my picture below, I can see that I have 6.5 is my length, my width is 2, and my height is 2.5 inches long. Now when I look, it says how many small cubes, so we're looking at the small cube, how many of these can I fit in and start lining up in my box? So imagine visualizing this. You take that very small cube and you're placing it. Now remember, it says it's 1/2 by 1/2 by 1/2. So all of those sides are 1/2. And it says, okay, how many of those will I need? Well, let's do that first and then we'll find the volume. So imagine placing, and I'm going to be a terrible drawer, but imagine placing like little cubes here. And it's asking, okay, how many of these little cubes do I actually need to fill in this space? And when we're trying to figure that out, that's really what we really need to do is we need to take our length, which in this case is 6.5, and we need to divide it by the length of that cube just to see how many of those will fit. So if the whole length is 6.5 and each little one is 1/2, then we can divide them to see how many we need. And you're used to doing this, you just don't realize it because this one's a fraction and normally it's not. So before I can divide these, I need to take this number, the 6.5, and I need to change it to an improper fraction, which remember it makes like a big circle. So I'm going to do 2 times 6, which is 12, plus 1, which is 13. So it's like 13 over 2. And I'm dividing that by 1 over 2. So again, I just wrote down the exact same problem. I just changed this 6.5 to an improper. Now I can do, okay, I'm going to do keep, change, and flip. So I'm going to keep the first. Remember, when we're dividing fractions, we do keep, change, flip. Keep the first fraction. I'm going to change the sign. So instead of division, it's multiplication. And this is like multiplying by the reciprocal here. And then 1/2 becomes 2 over 1. And when I do that, I can just multiply straight across if I want. But we're going to use a trick. So in math, when we're multiplying like this, if you have the same number on the top of a fraction and then on the bottom, they actually cancel each other out. You can divide them out. So if you look here, notice there's a 2 on the top, on one of the tops, and a 2 on one of the denominators on the bottom. So they actually cancel, which means I'm left with 13 over 1, which is just 13. Okay, so what does that number represent? Well, let's think about what we just did. We wanted to know how many of those little cubes we could fit along the length. And when we divided that, we found 13. So that tells us that we actually can put 13 cubes along this length. Now we're going to do the width. So when we're looking at the width of our rectangle, again, we're going to take the width, which is just 2, we're going to divide that by the width of our cube, which is 1/2. So what does that give me? Well, remember, we have 2 fractions here. Now, if you ever have a whole number like this, you can just put it over 1. And this would be like keep, change, and flip. So keep the first, change the sign of the second to a multiplication, and then flip the 1 over 2 to 2 over 1. Now, this one doesn't have the same number on the top and the bottom. It has the same on the top, on the numerators, but that's okay. So I'm going to multiply straight across. 2 times 2 is 4, and then 1 times 1 is 1. And 4 over 1 is the same thing as just 4. So that tells me that if we were to line up cubes going this way, we would only have 4 of them. 4 cubes that would fit the width. All right, now let's go ahead and find the height. How many can we stack high? And to do that, we take our height, our total height, which is 2.5, and we divide that by the height of the cube, which in this case is 1/2. Okay, so the next thing I need to do is I need to look at this and say, well, I've got to divide this, but before I do, I need to make this improper. So it makes this big circle, and it's really saying 2 times 2 plus 1. Well, 2 times 2 is 4. 4 plus 1 is 5, and then it's divided. It's over 2. This denominator will be the same. Then I'm dividing that by 1/2. And again, now that we've got them into 2 fractions here, like this improper, we're going to do keep, change, and flip. So I'm going to keep the 5 over 2. I'm going to change this sign to a multiplication, and I'm going to flip the 2 over 1. Now, remember, you can always multiply straight across. There's nothing wrong with doing 5 times 2 and getting 10, doing 2 times 1 and getting 2. Nothing wrong. But if they have the same number on the top and on the bottom, they cancel. So these two actually cancel out, and you're left with 5 over 1, which is just 5. So what does that number tell us? That tells us we can put 5 cubes going up our rectangular prism. So in this question, it says, how many small cubes with side lengths would you need to fill the box? Well, you would have to have 13, 4, and 2.5. Now, if you wanted to find the volume of that, remember volume is always the length times the width times the height. So you would take your numbers that you got, your 13 times your 4 times your 5, and you would multiply those. And it doesn't matter the order in which you multiply those. I'm going to do 4 times 5 first, just because that's easy to me. 4 times 5 is 20. And then it would be like 20 times 13. Well, I know that 13 times 2 is 26, and then I'm going to add my 0. So 260 inches. And then since it's volume, we're going to put cubed. All right, we're almost done with this problem. So remember we had 13, 4, and 5, and we used those to find the volume. But remember, each of those is based on the fact that your cube is 1 inch each side, and it's not, it's 1/2. So I would write this in your notes so you have it. But to find the volume of your prism, you're going to find the total number of cubes that you have, which in this case, we just took our 13, our 4, and our 5, and we multiplied them and got 260. It's almost like finding the volume of that rectangular prism. And then you want to multiply that by the volume on the small cube. Well, the small cube is 1/2 by 1/2 by 1/2. So let's do the volume up here real quick of that one. 1/2 times 1/2 times 1/2. That's our length times our width times our height. And that's 1 times 1 times 1, which is just 1. 2 times 2 is 4. 4 times 2 is 8. So our volume of that very small cube is actually 1/8 inches cubed. Okay, 1/8. So we're going to really have that times 1/8. So you're going to take basically what you get, the 260, which is how many cubes you'll need, and you're going to multiply that by the volume of the small cube, which is 1/8, because it's going to be 1/8 of that size. So I just put this over 1. 260 times 1 is 260. 1 times 8 is 8. And then my last step is just to divide those out. So how many times can 8 go into 260? Well, let's see what we know. Well, 8 can go into 26. Let's see, 3 times? 3 times 8 is 24. And when we subtract that, we get 2 left over with the 0 we bring down, which is 20. So I say 8 goes into 20 2 times, which is 16. That gives us 4 left over. And 8 can't go into 4, so I'm going to have to put a decimal here and carry a 0 down. 8 goes into 40 5 times. So that tells me that my answer would be 32.5 as the volume. Now, if you're not someone who likes to find the cubes and multiply them and figure out what you have, another way to find the volume is simply just to take your length and multiply it by your width and by your height. So if it's just asking you for the volume, it might be easier just to take your length, which was 6.5, multiply it by 2, and then multiply it by 2.5. So if we did that, we could change these to improper again. So that would be like 6 times 2, which is 12, plus 1 is 13 over 2, times 2, which I need to make that a fraction by putting it over 1. And then I'm going to do this last one as well. So 2 times 2 is 4, plus 1 is 5. And remember our trick, if you have the same number on top and bottom, they cancel. So I can actually cancel this bottom 2 with this top 2. Or I could have chosen this one, it doesn't matter. So that leaves me with 13 times 5. So I'm going to do that up here. 5 times 3 is 15, carry the 1. 5 times 1 is 5, plus 1 is 6, and then over 2. And so I can do, how many times can 2 go into 65? Well, 2 goes into 6 3 times, which is 6. Bring down your 5. 2 goes into that 4 times. Oops, I'm sorry, 2 times, which gives us a 4. We've got 1 left over. And so that's where the 0.5 comes from, because we can add the 0 and 2 goes into 10 5 times. So I know I went really fast there, but I just wanted you to see that when you multiplied all these, you're still going to get 32.5 inches cubed for your answer. So one way to do it is to just multiply them together.